So I guess, do you think we should wait for anyone? Or when they arrive, should we just all stand up and applaud and they'll be really confused? Yeah? I'm getting a couple of nods. Okay, we'll see what actually happens. Hi everyone, my name is Ben. For those of you who don't know me, I'm pretty passionate about privacy and security and give talks about OWASP and various things in that space of how to help developers understand security more. So I'm not actually a security person per se. I've done a little bit of penetration testing and audits for companies who've inherited databases full of credit card numbers and all of those fun things. But most of my time is spent talking to developers and talking about security from a development perspective. So with that, I was doing a lot of talk about access control, and then who here is familiar with relationship-based access control? 2. Awesome. 3. So it's pretty new. I mean, it's been around, it's been used for a while. We'll have a look at some use cases to get an idea of where it's used and where it's useful. But what I wanted to do was do a real deep dive into how it works behind the scenes so that we understand where its power lies, but also where its drawbacks lie. So we'll go through that, and there'll be a demo at the end, and as I promised, it'll definitely not fail. It'll be fine. But before we get into that, a little bit about me. I've been a software developer for so many years that I've stopped putting the actual number of years up there, since 1999. I actually started in the PHP space. I know, it's okay. Actually, no, before that, I started in VBASP. Does anybody remember VBASP? You share my pain? Yeah. Then I got into PHP, done some front end, as I mentioned as well, security, auditing, that kind of stuff. But my real passion is in privacy, security, while it doesn't really lend itself well to the tech scene, also civil liberties, all of those kind of things wrapped up, making sure that people's data and lives are safe from the people they're not safe from. So over the years, I've worked in a couple of different places. I'm currently working as the head of developer relations for a company called ArcJet. We're a startup. We're still in beta. About to go into alpha soon, I believe. And basically, if you've got any API service, currently we're focusing on JavaScript, but we're about to bring out a Python and a Go SDK as well. .NET and others are down the line. But we basically want to put the security into the developer's hands again, and it runs in the middleware, so you actually get to control how the security works in your application, rather than getting confused when you deploy something into production and suddenly network layer security breaks your app. It's a pain. So totally free to use. arcjet.com, give it a try. That's all I'm going to say about it. On with the show. So, Access Control 101. Who here is familiar with access control in any shape or form whatsoever? Who here has a bank card and has taken cash out of a machine? That's a really bad question nowadays, isn't it? Everybody's using like Cash Apps or Venmo or whatever. For those of you who didn't put your hand up, I will excuse you because it is late in the day and it is hot and muggy and sweaty outside, and you've probably come, as the gentleman at the back there who I promised to pick on, you've probably just come in here for a nap, and that's fine. But most of us have engaged with access control in some way, even if it's a secret knock to get into your favorite speakeasy or typing a PIN number in to get your access to your cache, any of those things. I'm not going to talk about the really simplistic username password, yes or no. Can I log into my router at home? It's a yes or no. There's no real access control behind that. We're going to look at the ability to control what kind of access people have depending on certain attributes that they have. And there's 3 main things we're going to be talking about. Entities that are actually trying to access things, the resources, the things they're trying to access, and then the rules by which they are or are not allowed to access those resources. Who here has a dog? Okay, you're going to be my best friends. Who here has a cat and hates dogs? Of course it's you. So, let's have a look at ReBAC first. ReBAC is role-based access control. Familiar with that one? Most of you. So we'll go through this one pretty quickly. Basically, you have a number of roles. Roles can be considered like hats that you wear. You might be an administrator, a manager, an employee. You might be a guest in a building or in an application. And basically, you can assign a role or a hat to each person in your directory of users. So in this case, this is Shadow. This is actually my dog. Shadow is an employee, so he's not quite risen to manager level yet. He's working on it. As an employee, he will be able to access anything that employees can. Now, you can have multiple hats, but I don't trust him yet, so we're just going to leave him as an employee for now. And basically, if you apply a rule saying, well, only admins, managers, and employees can access this, then the door will open, and Shadow gets his bone. Which is hilarious, because I don't think he actually enjoys bones. He prefers chew toys and bacon. So, role-based access control, nice and simple. Attribute-based access control takes role-based access control and gives it a little bit of an elevation. You could say, correctly, that roles are an attribute. I might be an employee, you might be a manager, that's an attribute of our existence within an organization, for example. So role-based is attribute-based, but attribute gives you so much more on top of that and gives you a bit more flexibility about how you control things. So this is Min, this is Shadow's best friend. Min could be either a service dog, a good boy, loyal, or fierce. Can anybody guess which Min might be? Who thinks Min is a service dog? You are correct, she is absolutely chaotic. Would never be able to be a service dog. Good boy? Yeah, mostly. Loyal? Depends on her mood. Fierce? Absolutely not. Well, actually, Heather thinks she's fierce. She can scratch. She's an actual dog in my life. She can scratch quite badly. But most of the time, she just flops over and sticks her tail out, lifts her leg up and says, please scratch me. So she's mostly loyal. She's definitely not what I would term a good boy. So we're going to give her a loyal badge. And now we're going to define some rules about whether or not Min can get access to the bone. Now, who thinks service dogs should be allowed to have bones? Wrong. They are working animals, and they do not get a bone. Full stop. It's not a hill I will die on. I think the good boys and loyal dogs should get access to bones because they are living within the expectations of the societal environment in which they exist. So therefore, they get treated. To those of you who have a dog, or maybe this applies to you if you have any kind of pet that chews on things, do you let your pet sleep in your bedroom? A couple of you. Do you enjoy the sound of bones being crunched on at 3 a.m. while you're trying to sleep? No, we're going to layer an attribute on top of here and say, you can only access the bone between the hours of 9 in the morning and 9 in the evening. I do not want you chewing on bones while I might be asleep. Or playing World of Warcraft too late into the night. So we're going to add that on, and unfortunately for Min, it's actually 3 a.m., so she's not going to get access to the bone, which makes her very sad. But like I mentioned, attributes can be multiple different things. They can be identity, like who you've logged in as can be an attribute in some way. A lot of identity providers will allow you to add information into the JSON Web Token that defines a user, and that can carry attributes. So you can pull that out of the identity token. You could base it on physical location or network location. You can base it on the weather if you want. You're not allowed to read this file if it's sunny, because you should be outside playing with a dog. I think that's the rules that my dogs would set up. So you can have multiple different things with attribute-based access control. So let's move on to relationship-based access control. In the same way as attribute-based is based on role-based, relationship-based is not based on any of that at all. It's a completely redesigned paradigm into how to control access to systems. And in the first two examples, we had entities and resources. In a relationship-based environment, you only have entities, because a resource is also an entity. And what we're doing is we're defining the relationship between various resources to work out whether or not, various entities, to work out whether or not one entity can perform a certain action on another. So to do that, I apologize to the vegetarians in the room. We have Wilbur here, who's basically owned by a mad scientist. This is actually a dog, but apparently Dali made it. So, owned by a mad scientist. The mad scientist is friends with a farmer. The farmer has a whole lot of sheep. You can probably guess where the next line goes. Sheep have bones. Now, in researching this a little more in the past month, I found out that dogs shouldn't actually eat sheep bones. They're too small and fragile, and they can choke on them. So if you have a dog, do not take ideas from this. No sheep bones for dogs. Beef bones, cow bones apparently are better. The bigger the better. Side public service announcement there for you. So we've got this relationship building up now, and we can define whether or not the dog can get the bone based not on certain attributes or certain roles of the dog, but the relationship that connects the dog to the bone somehow. So here's an example. Sorry, let's make it a bit bigger. Here's an example of how you might define relationship-based access control here. You're actually defining it on the bone, because the bone is the thing that's going to have the action taken upon it. When you're looking at roles and attribute-based, you're assigning attributes and roles to the resource that's the entity that's making the request. In this case, you're defining actions that can be taken on an entity based on relationship to other entities. So in this case, the bone can be eaten by the animal's owner. Note that I'm not allowing the animal to eat its own bone. It's probably wise. So the animal's owner, the farmer, can eat the bone. The animal's owner's friend can eat the bone, or the animal's owner's friend's pet can eat the bone. And at the moment, we can see that everything aligns here with the friendship exists. The sheep belongs to the farmer, the bone belongs to the sheep in question, and the dog is owned by the mad scientist. Therefore, that third line there is valid, and the door opens. And the dog gets the bone. Now, the advantage we have here is that if any part of that chain breaks, the relationship is broken. So whereas before, if we wanted to deny access to the dog, to the bone for the dog, we would have to change either one of his attributes or its roles. We would be messing with the dog entity itself. But in this case, if they break friends, if the dog's owner and the farmer break friends, then that third line suddenly breaks and permission is revoked, even though nothing changed about the dog. Imagine if it was actually data in a database. We didn't change the dog record, we didn't change the bone record. All we did was we changed one of the relationships in the path, and that broke the whole cycle, therefore access is revoked. So you can see how this is very different to the way that role-based and access-based, attribute-based access control work. Does that make sense? All right, so let's go under the hood, because I want to understand how things get looked up. We'll see the complexities involved, which will allow us to decide whether or not it's the right thing for our particular use case. Is anybody familiar with the EAV, or the entity attribute value model? No. So this is, if you've ever worked with a content management system, and you want to create a new entity in that content management system through a user interface, it'll be using this kind of a model. Traditionally, when we design databases, we would have a table for dog, we would have a table for person, we would have a table for sheep, we would have a table for bone, and we would then relate those together in between those four tables. And if we decided that we want to have another entity, we would have to create another table in the database. Most of the time, that's not too tricky. But when you get a year or two down the track and your database has a lot of data, and you basically have to lock the database to make schema changes to it, that can be a very time-consuming and painful process. So if you're designing a system that's going to have a variable number of entities, not just at setup time, but also throughout the lifetime of the application, then an entity attribute value model will allow you to make changes to your virtual schema, the kind of information you can store without actually changing the physical schema. So first, I'm going to have a look at how that works, so we can kind of see how those things connect together, and that's going to help us understand the ReBAC model a little more clearly. So we have a table that defines entities. As I mentioned, if we want to add an entity, we just add a row into a table. And in this case, we've got two entities. We've got the user and an article. So looking at a CMS type system. And then we have attributes. Attributes of a user and attributes of an article, and also the values thereof. So we can see here the first two rows are for entity ID 1. So they relate to the user entity. We can see an instance ID. So this is instance 1 of user. If you look at the last two rows, you can see we've got instance 2 of user. Because we've still got user ID, the entity ID 1, which basically just says this is for a user, but it's got a different instance ID. So you can store multiple instances of the same entity in one table. So we've got a user, Robin, with a password. And the bottom two tell us we have a second user with user ID 2, the username Morgan, and a password which is the start of a JSON Web Token. I think they think that's more secure. And then the middle two rows we can see is for entity ID 2. So this represents an article. Then it's article ID 1. So even though Robin's data at the top there is instance ID 1, so is article, but this is of type article. So again, there's a uniqueness about those two in the middle. They're for article 1. And we can see the title for article 1 is the ReBAC for the win. Content is can has FGA, fine-grained access control. And we can pull these out with a simple-ish SQL statement. For those of you who love SQL, you'll see here we've got a join between entities and attributes. We're basically saying pull out everything where instance ID is 1 and entity name is article. So we're actually looking at both the attributes table and the entity table in this select to filter out. And this is going to give us the title and content of article number 1. So you can pull out entity information and all of its attributes in one SQL query, or alternatively, you can make requests that say pull out all the users, but only show me the username. And that would then allow you to get a list of all users, but not necessarily all the attributes. So there are two ways you can query this. There are a number of different ways you can query this. But you can see that there's two different perspectives here on the same data, and the underlying data hasn't changed. We're able to get a list of things out. We're also able to get all the attributes of a single thing out. And then, as I mentioned, if you wanted to add an entity, we just basically add another row in there. We're going to add a comment entity, entity ID 3, and then we can add 4 extra rows in. These are all for entity ID 3, so they all pertain to a comment. They're all instance ID 1, which means they're all comment number 1. And then we've got an attribute in there, which is the article ID. So now we're actually linking to another article. So article number 1 has a comment from Sam that says first, and it's got a timestamp. And we didn't have to make a schema change for this. We've now got comment functionality in our application. It's pretty cool. So how does a ReBAC model fit on top of that? It's quite similar. And we still have an entities table because we've got all the entities. We've got the dog and the person and the farmer and all entities that are talking to each other. So let's consider 3 different entity types, the user, an organization, and an article. And in this case, each of them have got a name. So entity ID 1 is a user called Robin. Entity ID 2 is an organization called Acme Co. And entity number 3 is an article called ReBAC for the win. Now you'll notice here that this is basically a flattened version of the EAV model, because in this case, we're not so concerned about looking up, getting attributes out to render. The EAV model we just looked at would be great for a CMS because we can say, okay, we were going to render article 1, so give me all of the information about article 1. Here we're talking about permissions. We don't actually need all the information. We just need a representation of an entity in the system. So we have 3 entities in the system, and we've got the flexibility to define the entity type and also give it a name. And now we're going to define relationships between them. And you'll see here we've got a subject entity ID and an object entity ID. That's because, as I say, we don't really have resources. Every entity can be a resource. Every entity can also be the primary entity that we're asking questions about. The dog can be an entity, the bone can be an entity, and they link together somehow. So we're going to say that subject entity ID 1, so that's Robin, is linked to an object somehow. In this case, we're looking at the article. And the link, or the relationship type, is owner. So this entry tells us that Robin owns. Now, this doesn't tell us anything about permissions yet. The owner part there is just a label. And if you think of any access control mechanism, going back to role-based, for example, you give the role a name, like owner. It doesn't actually mean anything until you assign that role permissions. So in this case, we've got a role of sorts, or some kind of relationship between these 2 entities of owner. We're also going to say that Robin is going to be a member of the organization. So again, Robin is the subject, and the object that we're looking at is linked to Robin as a member type, or a member relationship. We're also going to add another user now. So Morgan has just joined the organization. Morgan is also a member of organization, represented by entity number 2. And now what we're going to do is add a 4th one in, where we're going to take the subject as being the organization, and the object being the article. So the organization can view the article. But that doesn't really make sense, because organizations don't read articles. People have access to articles. But we also have an entity relation over here. So at this point here, what we're saying is that members of organization 2 are a viewer of article number 1, or entity 2 in this case. Does that make sense? This is why I wanted to do the EAV first, because this starts falling apart in terms of cognitive ability to map everything together. But essentially what we're doing down here is we're adding a single rule in as a relationship, and now if a 3rd person joins the organization, they automatically inherit that viewer relationship type with article because they are a member of the organization. We don't have to add a new relationship in, because that exists. And then we can define I was supposed to click a couple of times for that. There's the member part. Then we can define the actual permissions. So we've got the entities defined, a single row per entity in our entire system. We've got relationships, so we know how they relate to each other. And we've even got indirect relationships, where we say, generally, people in this organization have access to something. Now what we want to do is come and add permissions, or you might hear of them as scopes in certain situations. So we're going to define for relationship ID 1, which is the fact that Robin owns the article. That relationship type means that Robin has read access. And then we're going to add another one in. You'll notice permission ID increases just because you have an ID, but it's not related to anything else. It's still relationship ID number 1. So the fact that Robin is an owner of the article means that they also have write access. And then we're going to add a third one for relationship ID 4. This is this compound magical one down here that says all members of the organization are viewers. We're going to give them read access as well. So now we can do those complicated SQL queries and pull all of that together and say things like, who has read access of this article? So in fact, let's do that and step backwards. This is the data we have. So how would we work out who has write access, for example? So the first thing we do is we look at the permission. We say we want to know who's got write access. And we can see that's also highlighted relationship ID 1 in the relationships table there, because we've got that link. So we can now say write access is applied to all of these relationships. In our case, there's only one of them at the moment. And then we're going to say, well, the query we have is about the article. So let's find all the relationships that relate to the article. There are 2 of those. But we can scrap the fourth one straight away because the relationship ID didn't match. So we want to find all relationships that have a permission that are linked to that write permission that are also associated with the article. And now we can pull out the subject entity ID, and we can say, okay, cool. We know that Robin has write access. We don't actually care about the label at this point, that they're an owner. That could be, they're a sheep. It's just a label. But we can now look out through a query lookup who has write access to this document. And conversely, we can do the same for read. So for read access, we've got 2 permissions there, which means that relationship 1 and 4 both have read access. In this case, we're going to, again, filter by the article, and both of them are valid. So both of these relationships have read access. We've already seen that we can just pull a subject entity ID out, and that links to Robin. So we know that Robin has read access. And now we know that entity ID 2 has read access as well. But because we have an entity relation on that, we need to do a second lookup. So the organization is the entity that has access to the article. We now need that organization to no longer be the subject, but to be the object. Who is related to that as an object? So now what we do is we see that the relationship type is member. We can find those members there. We can also filter by that too in the second column, because again, organization, which is ID number 2, has now become the object of our query. And then we can find out that user 1 has read access. We've already worked that one out. But also the user 4 has read access. So now we can determine that Morgan has read access to this. So we've got a massive amount of flexibility in the way we can define. It's really hard to look at as a human, though. So management of this requires good user interfaces. We've got a huge amount of flexibility in the way we can define entities, their relationships, and the permissions that those relationships infer onto a system. And again, if I'll repeat the question to make sure I got it right. So we know that entity ID 1 has access because that's in the permission table. We know the relationship 4 has access, and then we're inferring from that the people within that organization. So that's correct. So, for example, if Morgan left the organization, then line number 3, the relationship line number 3 there would be removed. And therefore, when we did that lookup of find all members in this organization, only Robin would come up. Yes. trying to make sure I'm getting my names right, only Robin will come up. So Robin would have read access both by virtue of the fact that they've got permission ID 1 there, because they're the owner, and also permission ID 3, because they're a member of the organization. And if any of those relationships break, like Morgan leaving the organization, that permission to that file disappears. All right, that was heavy. I'm going to lift us back out of the trenches. I hope that made a bit of sense and at least gave you a perspective of what's going on under the hood. The idea is you'll never actually have to implement this unless you work for a company that provides relationship-based access control as a service or internally. But most of us will never have to look at that level of detail, but it's good to understand what's going on under the hood and the complexities of it so that we can then understand, and we'll come to that a bit later, what the implications are of making this choice. So let's have a look at actual implementation details. These are the kind of things that we as developers are going to be looking at. So we might already be familiar with some of the business logic behind ensuring that you can only edit an article if you're an admin or an editor. If you are an editor, that you are allowed to edit that particular article. And if the article is sensitive, we also want to make sure that the person who's doing the editing is actually on site within an office, and they must be doing it during office hours. So that's not an unreasonable set of rules we might have over access to a document. And if we did put that into code, we would say if the user is an admin or the user is an editor, and on top of that, if they are an editor, also make sure that if you look at the list of editors for the document, that they exist in that list. And we also want to make sure that the document is either not sensitive, in which case we can carry on, or if it is sensitive, we want to make sure that the user is on premises, or rather their location is on premises, or their location is in office hours. So no matter where they are in the world, we can use time zones and normal working hours to work out, are they actually in the office during their working hours? And if so, they can also access sensitive documents. It makes sense when you step through it. If you had to come back in a few months' time and change some of the logic because there was a change in requirements, you'd probably have to spend a little time working through that. Ideally, you'd probably document it a little bit, but there's still, and also if you're changing this code, you don't know what the knock-on effects necessarily are to other applications, other areas of the application. So it'd be nice if we didn't have to put this into business logic, because there's not really business logic when you think about it. It's access control, which in my view is best handled, especially when it comes to complex access control, in my view is best handled as a separate function of a system. So let's write this in some kind of policy document format. And they vary, so you'll see a few different format types as we go through some of these demos. But we're going to have a document, and a document has an owner, which is of type user, and an editor, which is of type organization, but with that member editor. So that's how in some formats you would do that fourth line. Whereas the editor member type, editor relationship type on the organization. So organization editors and users can access this. You'll note that user doesn't force us to make sure they're admins or anything, because that's something you define when you're actually adding entities into the system. This is defining the schema of what we're going to store, not the actual information that we're going to store. And then we're going to extend that document as a relative extension of the document. And we're going to have an edit action on that. And in there we can say, is it within working hours? And we can put functions in that will actually run some small parts of logic that will allow you to make true-false statements about a certain environmental condition. Is it within working hours? And if it is the person who's trying to edit, so is the relationship to this sensitive document an owner of the document? Or, and is that owner also on premises? Or is it an editor of the document, and that editor is also on premises? So we've got exactly the same code in a different format, but this now applies not to that little bit of code in your application. Remember, your application is making a request and then checking before it logically allows access. At this point here, we're stopping our application from ever getting access unless these rules are met, because it's a layer in front of the actual access, the actual content management system, or document management system, or whatever we're protecting. So our application doesn't need to worry about this anymore. So we can take all of this code here, and we can replace it with one line that just says, let's use our ReBAC module, let's check to see whether the user has edit permissions on the document. And now if we need to change the rules behind whether or not they do have access, we change it within the permission management system. And this will automatically update. And anywhere else that has also needed to access something will automatically update, without us having to make sure that all of our code is up to date. So, some use cases. We'll go through these pretty quickly, and then we'll get into some demos. Hospital patient records. This is one that actually came up in a contract that I was doing a couple of years ago. They wanted to make sure that nurses, as they were on roster, so this is where the office hours came in, their roster hours were actually very different to a standard 9 to 5, so we had to make sure that they were actually on roster, that they were assigned to that patient, and if they were reassigned to another patient, or rather that patient was no longer assigned to them, then the relationship would break automatically. That's a really good example. A similar one is corporate calendar access. So in the same way as a nurse or a doctor has access to patient records, an executive assistant would have access to a director's calendar. And if they're moved to another office, and suddenly there's somebody else's executive assistant, or they move to another company, then the fact that the relationship between them and their manager or their boss has been broken means they now no longer have access to the calendar. Often, traditionally, most of the, like if you look at Outlook and Gmail and all of those, you can assign somebody to manage your calendar for you, and you specifically go in and you find a person and you link them, and if that person should no longer have access, you need to go and break that link specifically. Whereas if it could be controlled through a ReBAC model like this, then you wouldn't need to worry about that. You've got automatic offboarding in place. Project management systems. When you drag that Jira ticket that you finally finished into the testing column, you don't need to look at it anymore. So you can define who has access to tickets or any kind of project management documentation, depending on where the application is or where an issue is in the pipeline, where the teams are. If it gets rejected by testing, it gets put back into a certain column, then suddenly you've got access to it again. Generally, breaking that based on the relationship is a much more consistent way of making sure that the data that's out there is only accessed by the people who need to see it. And social media platforms is probably the most common example of this. A user can like or read a post if they are friends with the poster. If they're no longer friends, then suddenly they can't see it, they can't like it, they can't interact with it, they can't react to that at all. And then, yeah, so if they forget to invite their friend to a birthday, maybe they break friends. So with that, let's go and have a look at demo. I have, actually before, no, it doesn't really matter if we do before or not. I've got a slide with a list of a whole lot of different providers that do, I'll bring it up. There's a few slides here, let me just scroll back to the bottom. There are a number of different providers out there who offer ReBAC-based solutions. So this is just a small selection of those. I'm using Permify for this demo. I've tried Permit. They're pretty good. One of the reasons why I'm not using Permit for this demo is that because they support RBAC, ABAC, and ReBAC, the way they do ReBAC is a little bit different in that entities can't be related to other entities, or users can't be related to other users in the system. Any other entity can be related, but because of the fact that users can fit into all three models, they've made a decision that users can't be related to each other, so that doesn't work for this demo because a user is a representation of somebody who can take an action. So I wasn't able to relate the dog to his owner. There's Andrew Cortese down here. He's got his own open source project as well. Most of these have, I believe, a free option. I like Permify, so that's the one that this demo is based on. So let's have a look at those. Who likes Postman? Nobody. 3 people. So I am going to, here, just get this started. So there's one thing I like about it is there's a Docker image. If you just want to play around with it, you can just start the Docker image, and I've got Permify running here. This is now running on my local machine, and it basically provides a REST and a gRPC endpoint for interacting with the system. It doesn't come with a graphical user interface or a web admin dashboard or anything. Everything is done through, hence postman, done through this. So what I've done is, let's just bring this one up, because the way that you put the schema in isn't very readable on a screen. So I've also got the schema here for us to have a look at. So we've defined 4 entities in our system. We've got our dog, we've got our person, we've got our sheep, and we've got our bone. A bone has a sheep of type sheep. I wasn't sure what to call the relationship, like skeleton, carcass, I'm not sure. So I decided that the bone has a sheep. You can also see the sheep has a bone. So we've got this two-way relationship between them. Sheep has a bone of type bone. Sheep also has an owner of type person. Dog also has an owner of type person. Technically, I guess dogs have bones. I probably could have modeled that more generally as an animal. But because of the way the permission systems work, I wanted to keep those separate. And then a person has a friend, which can be another person. So you could potentially have this huge big chain of lots of friends. And because friendships can be two-directional, you can actually say, look, I'm friends with this guy over here, but he doesn't think I'm a friend. So you can model that too. It's a strange relationship, but it works. A person has a sheep and a person has a dog. Now, in this case, there's no specification of how many. So a bone can have multiple sheeps, technically. But that's just the schema, right? You would make sure that you don't actually model that when you put the data in. And you'll see the way the permissions work here is interesting. What I would have liked to have done down here is permission eat, just make sure my head's not in the way. So the permission eat on the bone. What can eat a bone? What I wanted to do was say the sheep.owner.friend.dog, which would have followed that path. And in some access control models, you probably could do that. One of the limitations of Permify is they don't allow you to walk across that tree more than 2 nodes. So I can do, I would be able to do sheep.bone, although the bone shouldn't be able to eat itself. I could do sheep.owner, but I couldn't do sheep.owner.friend. Once it got to friend, it said, I'm not going to do this. I'm sorry. You're out of luck. So what I've done instead is I've chained some permissions together. So bone can be eaten by the permission resolution of sheep.owner's dog or sheep.owner's friend's dog. And then we've got 2 permissions in sheep. So the owner's dog is owner.dog. That's the end of that chain. That's actual entities, but it's only 2 of them, so Permify is happy with that. Owner's friend's dog is owner.friend's dog, and friend's dog is another permission lookup. So then if you look at the person, you can see we've defined friend's dog as being friend.dog. So if you imagine this as being nested functions, essentially what we're saying is the sheep.owner.dog or sheep.owner.friend.dog can eat the bone. Does that make sense? No nods, so I'm going to assume not. But we'll have a look at an actual demo. So I'm going to take that, and let's make this bigger so we can see what's going on. Maybe not quite that big. So you can see here, that's the format it wants it in. It just wants it as a text blob with /n's for new lines, and I didn't want to describe what was going on by looking at this. So the first thing I'm going to do is create a tenant. So what Permify allows you to do is have a multi-tenant architecture, so you can containerize is probably the wrong word because containerization means something. You can silo data together into logical organizations. So I'm going to create one called dog and bone, and then I'm going to create the schema inside that dog and bone tenant. So that's come through. You can see down here we've got a schema version has appeared. And now what I'm going to do is create some relationships. So if we look at the relationships here, they're set up as tuples, and you have a subject, a relation, and an entity. And because the Permify documentation for some reason sorts by key alphabetically ascending, it's wrong in my head. So I always read it from bottom to top. The sheep is a sheep. The sheep is a sheep of the bone. Because the bone is not a sheep, right? So the relationship between sheep and bone is that sheep is the sheep of the bone. I know. We can also say the bone is the bone of the sheep. So this bone is the bone that belongs to this sheep. So there's a relationship that can happen. So we've got that two-way thing going on. A person is an owner of a sheep. A sheep is a sheep of a person. A dog is a dog of a person, and a person can be an owner of a dog, and that's it. That models our 4 entities together in exactly the same way as we were looking at in the example of the schema. But we're actually defining now the mad scientist, the farmer, Shadow, Dolly the sheep, because of course it had to be Dolly the sheep, and we're making sure that it's a femur because we want to make sure it's the biggest bone so that Shadow doesn't hurt himself when you choose on it. All right, so let's create those relationships. Hit enter on that. We've got a snap token. So one thing I like about Permify is that it'll give you back this snap token, which is basically like a snapshot in time. So when you're making future requests, you can actually you can cache based on that, and if the snap token comes back differently, you can say, okay, I've got new data. You can make requests and optimize based on that, because there's a lot going on under the hood. If you can reduce the amount of requests you actually have to send to Permify, then that's a good thing. We could now read all the relationships out, which is basically going to repeat exactly what we had, so I won't read that to you. And one thing you'll notice that we didn't do in there was define a friendship. So if I execute this one here, which is basically calling relationships read, and we're saying in there filter out by mad scientist's friends. So show me all of the friends of the mad scientist, and we've got an empty array down here. Nothing's come back. So there's no friendship created yet. They haven't met, but they're going to be great friends soon. So now, can Shadow eat the bone? So we do a call to permission check. We want to check a certain permission. What we want to do is find out whether the subject, Shadow, can eat the entity bone. And if I execute that, you can see that in the bottom or there already, check result is denied. You can see that it's checked 5 different graph permutations of trying to get the information together, so it's actually looking at multiple ways that relationships could be built, and none of those resolved, therefore eat comes back as false or denied. So if we make friends over here, I'm going to call data.write. I'm going to create a single entity in here. The mad scientist is friends with the farmer. If I execute that, we can then run can Shadow eat the bone again, and it comes back as check result allowed. That's boring. That's just text. So what I've also done is created a React app for this. Let's just refresh that. So what this is doing, where's my code? There we go. So what this is doing, we've got a number of functions here. We've got this check permission. I want to show you the code just to make sure that you know that I'm not cheating, because I was considering cheating earlier today when my demo broke. But I'm happy to have gotten it running, so I'm going to show off. You know? So we've got a check permission here, which is exactly what we saw in Postman. We're making a request to permission check, and we're saying find out whether Shadow can eat the femur. And we've also got another one here called make friends. We're going to data.write, and we're going to add this tuple, the mad scientist is friends with the farmer. And you'll note, when this function ends, we don't do anything else. So I'm not magically updating a flag somewhere to cheat, which is what I almost did. Obviously, we wouldn't have admitted that if that had been the case. But, and then we've got break friends, which is calling data delete. It takes a slightly different format. We're going to provide a tuple filter. So what we're doing is we're filtering by entity type, person with the ID of mad scientist, and the friend being the farmer. So with that running, I should now be able to break friends, and the door closes, and make friends, and the door opens. And what that's doing in the back end is just making and breaking that relationship between the two users, the farmer and the mad scientist. And what the door is, the state of the door is based on that permission check, which is totally independent of the relationship. That make sense? So, just in closing, some thoughts around whether or not you should use this. Because it's all very well finding out about something awesome and complicated, but if we don't know when it's the right thing to use, we're probably going to be implementing things that shouldn't be implemented in certain cases. If you are a modem manufacturer and you want somebody to be able to log in to configure your home internet, you probably don't need relationship-based access control. Mostly because you don't want to be running Permify on the router, so let's not do that. There are cases where simple username and password is absolutely fine, and if you're authenticated, then you're in. Sometimes you want role-based, sometimes you want attribute-based. If you find that role-based or attribute-based do not solve your problem, then that's when you might consider relationship-based access control. So the source of where ReBAC came from was a Google project called Zanzibar. Anybody familiar with Zanzibar? A couple? So the problem they were trying to solve was, how do we manage permissions and, I guess, just permissions within something like Google Drive? You've got a huge number of directories, you've got departments, you've got teams, you've got organizations, you've got people. How do we make sure that when a file gets put into a certain directory, it automatically inherits permissions from its parent? It's the kind of thing that has traditionally been done in a lot of business logic. And that's probably how a lot of our applications, if you're doing anything of this complexity, unless you've implemented ReBAC, you're probably familiar with the amount of business logic required to make sure that all of the checks and balances are in place to make sure that access is only allowed to those that really should have it. And probably your test suite is most heavily pointed at making sure that that's the case, because there are so many legal regulatory issues. If you get that wrong, especially if you work in something like finance or health or any of those kind of things, you really want to make sure that your access control is nailed down. So if you're in a situation where relationships between entities suddenly makes your life easier in terms of providing that access control, I would highly recommend looking at something like ReBAC. But remember, when we went through how it works under the hood, how complicated it is. So a lookup is not trivial. You don't need to worry about it because it's all encapsulated in whichever platform or tool you use, or unfortunately, maybe you do have to write your own. I was talking to somebody a while ago who works for, I can't remember which defense, I think it was the UK defense. And they said, yeah, we can't use any of these products, we can't use the open source ones. And I don't think any of the commercial ones are based in the UK. So they weren't able to use any of them. So unfortunately, there are going to be some situations, hopefully it's not you, where you will have to write your own. But yeah, I went off on a bit of a tangent, as I tend to do. If that chair scraping is really annoying me all of a sudden. Lost my train of thought. If you're complexity, if you are going to implement it, remember that there's a huge amount of complexity under the hood. There are caching options. We saw how Permify use snap tokens. Look into that more if you are going to implement something like Permify. But do bear in mind that it is going to put an extra load on your systems. It's not a trivial process. So that's the point I really want to drive home if you're going to choose it. But if you do choose it, it is so much fun to play with. And once you really get into the configuration, once you've got all your policies set up, as developers, there is so little for you to worry about. It's actually going to be a joy to work on those parts of your application again. At least that was my experience. So I hope that's been useful. I hope the explanations weren't too mind-boggling, especially this late on a Thursday on a warm, sweltering day. I believe there's one more session, so we're not quite going to be going for beers yet. But if you want to ask questions later, you're more than welcome to find me. I'll be over there. If you want to ask questions now, we've still got a bit of time, I think, 12 minutes. So, yeah. So thanks for your time, and I hope it's been good. And I think you might have a question.
And when you were saying about walking the tree,
yes.
You were kind of creating aliases.
I guess you could call it that, yeah.
And they gave it a shortcut that allowed it to simplify.
Right. So the question was, when I was talking about walking the tree, I was effectively creating aliases when I was defining those permissions. So an alias, or a kind of like a function, I guess, and then chaining those together to achieve a longer tree traversal to make that happen. Yeah. Cool. All right, well, thanks for your time. Enjoy the rest of the conference, and hopefully I'll see you for a beer later.